Yeah. 7 married couples were seated at the first row of a small theater. How many different seating arrangements are possible? Okay, so let me bring that down to here. So clearly order matters. I mean, that's the whole thing that matters on this one, right? Is what order they sit in. So when order matters, what do we always do? Decisions, options, right? That's in the notes for you. Well, I don't know where I put the notes. Up here's the notes, exam 4 notes. So when order matters, the possibilities is number of options for decision 1 times number of options for decision 2 times etc. You just multiply those together. When order doesn't matter, we do something totally different. But order matters, it's decisions and options, multiply together all the options for each decision. Okay, so that's what we're talking about here. Order matters, the order in which they sit. Now, I always encourage you to actually do it. So how am I going to, this one's a little tricky. I've got 7 couples. I'm going to go husband 1, wife 1, husband 2, wife 2, husband 3, wife 3, husband 4, wife 4, husband 5, wife 5, husband 6, wife 6, husband 7, wife 7. So you can do it however you want. So now I'm going to do an example. I'm going to actually seat them. Here we go. Here's my example. I'm going to go, I don't know, wife 3, followed by husband 7, followed by husband 8. No, there's not an 8. Husband, whatever, some other husband. Husband 4, followed by husband 3, followed by wife 2 and wife 1, and then husband, etc. You get the idea, right? I'm just kind of picking at random. So how many decisions will I make? They just said seat them however, right? Just how many different seating arrangements are possible? Well, if they can just sit however, willy-nilly, let's just think about 3, 4. I made 14 decisions, right? There's 14 people. 7 married couples is 2 times 7, 14 people. So decision 1, decision 2, decision 3, decision 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Decision 5, decision 6, decision 7, decision 8. Oops, I'm ahead of myself. Decision 9, decision 10, decision 11, decision 12, decision 13, and decision 14. So for the first decision, now we're going to put the options up here. How many options did I have for the first decision? I chose wife 3. I had 14 options. I could have put any of the 14 people in the first seat, right? Next, husband 7. How many options? Well, 13. And then 12, and etc., right? All the way down. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's going to be a gigantic number. So if you do that on your calculator, let me do that. Give you what I get. I'm getting, here's what it comes out on my calculator, something terrible. I get 8.717, 829, 1, 2, and then I've got this E10 thing. Every calculator shows it different. I don't know if you've seen that before. You know what E10 means? It means move the decimal 10 places to the right. It's exponent. It stands for, it actually means times 10 to the 10th. It's actually scientific notation. I don't know if you remember scientific notation from Math 10A or previous math courses you've taken. Means you got to move the decimal 10 places to the right. Doesn't really belong here. So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 places. So you got to go 2 more, don't you? So 1, 2, and those bring in zeros. So when you go beyond the edge of the number, you bring in zeros. So 10 places to the right, the number will become 8717, 8291200. And the decimal ends up right there. So that's my answer to the first one, 8717, 8291200. Gigantic number. Lots of ways those 14 people can sit. You know, if you put in comma, you know, don't put in commas in your answer, but just so I can see it. What is it? That's 87,178,291,200. 87 billion. We're getting close to the national debt at that, but we're only halfway there, maybe less. But anyway, big number. A lot of different ways those 14 people can sit together. Are you okay with this decimal thing? Do you understand what that means? E10 means move the decimal 10 places to the right, or whatever notation you get on your calculator. Take the decimal where it was, 8 to the right, get you to the edge of the number. So then you got to move 2 more beyond the edge, which brings in zeros to get 10 places to the right. It doesn't actually bring in zeros. We just don't know what those last 2 digits are. The calculator's not showing us, so we just assume they're zeros. And that's the answer the homework system will take. Now, for part B, that's all part A. Now, coming on down for part B, now we're going to say married couples must sit together. So if the married couples are sitting together, how many different arrangements are possible? Well, again, the best thing is to actually do it. You know, I really encourage you, just do what you're trying to figure out. Let me do an example. Here we go. I'm going to go, all right. Husband 3, wife 3. Right? They're going to sit together in that first couple spots. And then, I don't know, wife 7, husband 7, next spot. And then wife 4, husband 4. And then husband 6, wife 6. And then husband, what are we missing? 1, wife 1. And then wife 2, husband 2, 1, 2, 3. Oh, I'm missing one, aren't I? Whoops. What am I missing? 1, 2, 3, 4. Missing 4. All right. Wife 4, husband 4. There we go. All right. So I just did it. It really is helpful to actually physically do it. Sorry about messing this up here. Let me try this again. Husband, what was it? Am I missing 1, 2, wife 2, and wife 4, husband 4. There we go. All right. So I got them all.
Professor.
Question.
Is it 4? Did you put 4 twice?
Oh, I did, didn't I? What am I doing? Thank you.
I think it's 5.
Oh, is it 5? Thank you. So I'll put wife 5, husband 5. Thank you, Ruben. All right. So you're right. All right. So I got them all now. Thanks. All right. So now let's think back to what I just did, and let's think about decisions and options, right? Because order matters. Whenever order matters, our thinking is decisions, options. If order doesn't matter, well, we'll do that in a little bit. So I made decision number 1, decision number 2, decision number 3, decision number 4, decision number 5, decision number 6, and decision number 7, right? Okay, so for my first decision, I chose, how many options? Well, there were 7 different couples, right? There were 7 different couples. I chose to put that couple, the 3 couple in the first spot, right? Times, and then there were 6 couples, right? There were 7 different couples I could have put in the first couple of seats. And then there were 6 couples I could have put in the next couple of seats. And then there were 5 couples I could, it just goes down by 1 every time. You just pick in couples to put in the seats, right? But here's the curveball. Here's the wrinkle, the extra trick. That's not all. I also, once I chose this couple to sit in these 2 seats, I had to choose whether the husband would be in the first one and then the wife, or wife then husband, right? There were 2 options. You tracking with me? I could have done wife 3, husband 3, or husband 3, wife 3, either way. So there was actually 2 ways to arrange them. So I got to go times 2. And that goes for each of these. Each of these has an extra times 2. Do you see that? Because once you've picked the couple who's going to go in those 2 seats, there's 2 ways to put them in those 2 seats. Wife first, then husband, or vice versa. Husband first, then wife. You see the trickery there? That's the extra wrinkle on this one. So when the couples must sit together. You have 7 options for which couple comes first, then 6, then 5, etc. But for each couple, you've got 2 options how to sit them. Right? Wife first, then husband, or vice versa. All right, so that's it. Multiply all that stuff together. I mean, you can do it in any order. It doesn't matter. Just multiply it all together. And I'm getting 600, no, can't say it, 645,120. There we go, 645,120 options for how to seat them together when the married couples must sit together. So there we go.